some of you know okay, this class has a prerequisite of yesterday's class. So if you did not go through yesterday's class, most probably you'll not understand anything today. I won't recap a lot of what we did yesterday. So if you missed yesterday or if you don't know Docker already, today's class is going to be heavy, and feel free to drop off if that's the case. If you were in yesterday's class, then you should be able to follow along. We're still on projects.100xdevs.com Docker end to end. Yesterday, we did everything from slide 1 to slide 13. Today, we'll do everything from slide 15 to 20. Slide 14, I'll either cover in the end or in an offline video because this is fairly simple. I don't want to break the flow of today. I think when you initially join a class, you have a lot of motivation to discuss difficult things. So let's discuss all these difficult things, and this we can come to eventually at the end of the class or in an offline video. Quickly to recap, yesterday we did slide 1 to slide 13, understood what is Docker, what is containerization, history of Docker, how to install Docker, and some more, Docker specific constructs. Then around this point is when we installed Docker in our machine and started to run a few commands with it. Understood what was the Docker file. How can you create an image? How can you run an image? How can you pass an environment variable to an image? How can you do a few more things like Docker exec, which is something we discussed at the end of the class. Lastly, we were supposed to cover how you can upload your images to Docker Hub as well. We did not do it because we did not have the time, and I'm skipping it today because it's very easy. I'll cover it eventually or in an offline video. But today I want to first cover some advanced concepts. What are the concepts? We'll first understand what are layers. Then we'll understand what are networks and volumes. And then lastly, you don't see it here because this does not scroll right now. But lastly, at the very last slide, we will discuss about something called Docker Compose. So 4 things we are learning today: layers, networks, volumes, and Docker Compose. That's the goal for today's section. Let's get right into it. First thing you need to understand is something called layers in Docker. I'm repeating one more time. If you've not gone through yesterday's lecture, all of this is going to sound a little difficult. So yesterday what we did was we created a bunch of Docker images. We built those images and ran them. If you remember from yesterday's class, I have a few things here. We were running these commands like docker run a lot, docker run Mongo, or docker run -p 27017:27017 Mongo. This specific command would let us start a container on our machine. We also created our own Docker files and were running the docker build command, if you remember, using something like this. And then when we built an image, we eventually ran that image as well by using docker run backend, let's say. So this is what we did yesterday. And if you remember the Docker file from yesterday, let's see if I have it somewhere on my machine. Even if I don't, I think it's somewhere here. Let's see. This is what the Docker file was. This is the Docker file we wrote yesterday at the end of the class. From node 20, this is the working directory. Copy over the code, run 3 commands, expose a port, and then use cmd. All of this ran when you are building the image, which means all of this runs when you're running the docker build command. When you're running the docker build command, all of this runs. When you're running the docker run command, then this last command runs that actually starts your Node.js process. This is where we left it yesterday. But I said, if you remember, okay, this is not the most optimal way of doing Docker containers for a Node.js application. Before we understand what's the optimal way of doing it, we need to understand what are layers, because the reason they're not optimal is because they're not using layers effectively. Hence, the first thing we'll understand is what are layers in Docker. In Docker, layers are a fundamental part of image architecture that allows Docker to be efficient, fast, and portable. Very jargony. A Docker image is essentially built up of a series of layers, each representing a set of differences from the previous layers. So this is a little jargony of a definition. What it means is, okay, whenever you create a Docker image, whenever you run all of these commands one by one, command 1, command 2, command 3. It's creating layers for you one by one. It's creating something called a layer, and the final image is nothing but one layer on top of another layer on top of another layer on top of another layer. Eventually your Docker image looks something like this. There is a base image that you start from, which is this from statement right here. That's the central first layer. And then the second line runs, another layer gets added on top. Then the third line runs, another layer gets added on top, so on and so forth. Very similar to an onion. It's not a single sort of command. They run one after the other. First, this thing runs, which starts a base image. And when this succeeds is when you say first layer is done. Then the next line runs. And when this succeeds, you say the second layer is done. The second layer is only some extra things on top of the first layer. So the first layer will bring Node.js to your machine. It'll bring an image that has Node.js file system, all that jazz. And the second layer will just add a working directory on top. The third layer will just copy the code base. So if you find the diff between this whole layer, 3 layers minus the 2 layers, it'll just be, copying over the code base. They're incrementally being created. And there is a benefit of creating them incrementally, which is that you can cache these layers. If I have this from Node.js 16 Alpine in one Docker file, and I build that Docker file, and then I start another Docker file, I start another onion, which uses the same base image, then this layer and this layer can be cached. They can be reused. If I have 2 Docker files with the same base image, I don't have to get them from Docker Hub again and again. I can reuse this central layer. That's the benefit of introducing layers. If there are 2 Docker files, then let's say have 1, 2, 3, 3 lines exactly the same, and assuming the source code is the same, everything is the same, then the 3 layers can be shared between those Docker images. The final Docker image that is created can share these internal layers. That's why in Docker, layers are a fundamental part of the image architecture that allows Docker to be efficient, fast, and portable. A Docker image is essentially built up of a series of layers. A Docker image is just a series of layers, each representing a set of differences from the previous layer. This one has just Node.js. This has the working directory. This copies over the code base. This runs npm install, so on and so forth. So that's what layers are. How layers are made. The base layer, the starting Node.js or whatever image that you're starting from, that's the first internal layer over here. Then instruction layers. Anytime you write run, anytime you write copy, anytime you write workdir, all of these add a small layer on top. They add a small layer on top of the layer that came before them. Reusable and shareable. Layers are cached and reusable across different images. If there are 2 images that have the same base image they start from, this base image will be shared across those. And lastly, they are immutable. Once a layer is created, it cannot be changed. If a change is made, if I change this workdir to be /app2, let's say, then I can no longer use this second layer. This second layer will change, and every subsequent layer on top will also change. Anytime you change a line over here, or if you change your source code that is being copied, that layer breaks, and all future layers also can no longer be cached. They no longer can be reused. You add new layers on top. We'll see this visually very soon if you don't understand this very well yet. So this is a high level of layers. We'll understand them a little bit better as we run commands. But it's sort of an important concept to know in Docker, especially if you're optimizing Docker files. Let's understand layers a little more practically. I have a simple Node.js application over here, which is the same application we had yesterday. If you remember this application, we had a simple index.ts file inside which I had a basic Express server and some database Prisma as the ORM. And I had 2 endpoints, a simple health check endpoint and a post endpoint where you can create a user given the body email and the body name. Very basic application, does nothing. And yesterday we created the Docker file for it. We wrote all of this code, if you remember, And this is incorrect because we used node over here. I pushed this by mistake. But yesterday's Docker file was from node latest workdir /app. If you remember, it wasn't even all of this. I probably changed this in a commit. But if you remember from yesterday, the Docker file looked something like this. This was what the Docker file looked like. Let me also replace it in the code base so you guys get the same thing when you're cloning the repository. So this is the Docker file that we had written yesterday. Now we'll try to understand how layers work over here. When you've written code like this, how you're creating one layer over the other. If you look at it practically, these are the lines of code that are present in the Docker file. And as I said, anytime there is a from or a workdir or a copy or a run command, a new layer is created on top of the existing layer, which means if I've written from node on the top, the first internal layer is created. Then this adds another layer on top, so on and so forth. When you build the image, when you create the image given this Docker file, you will in fact see that layer 1 out of 6 is made. Layer 2 out of 6 adds a working directory. Layer 3 out of 6 copies over the code, so on and so forth. So Docker will actually give you this in the logs. Okay, layer 1 created, layer 2 created, so on and so forth. And notice it says cached over here. This is where the power of layers come into the picture. Okay, if you run this build command twice or thrice, you will see all of these steps or some of these steps will be cached. Why is this good? Because if you look at the first step, what is it doing? It's getting the node 20 image from Docker Hub. And this can take a really long time. This can take, some people yesterday was taking like 2 minutes. So if you have this already on your machine, it's a good idea to just reuse this layer rather than refetching it from Docker Hub, which is why caching is the biggest reason why you want to know about layers or want to care about layers and write your Docker file a certain way so that you're able to use the benefits of layers. What is the benefit? Caching. Let's try to run this specific Docker file locally. So try to clone this repository with the updated Docker file, bring it to your machine and try to run Docker build with me. If you don't want to, it's fine as well. It's a simple command. Either way, it doesn't matter. We'll just do it very quickly. So if you want, clone the repository. I'll paste it in chat. It's also present in the slides. So feel free to get it from the 16th slide right over here and clone it locally, open it in Visual Studio Code. I'm going to give you guys 2 minutes. Hopefully that's enough to just open it in Visual Studio Code. All right, 1.5 more minutes. You don't have to run any command. You don't even need to have Node.js on your machine. I'm sure you do by now, but you don't need to because we're using Docker to start this project locally. So you don't even need Node.js for what we're doing next. Why steps 2, 3, 4 aren't getting cached? We'll get to that very soon. I'm looking at Q&A for like the next 1 minute. Will the containers have separate OS? No. So depends on what base image you're using from. If you're using Ubuntu, your container will have a Ubuntu file system network kernel, not kernel, but operating system. And if you use a different base image, you'll have something else. Let's see. Difference between Docker and Docker Compose. We'll get to that towards the end of the class. GitHub link. We paste it in chat one more time. Oh, this is not it. 1 more minute and then we'll start, guys. Pasted it in chat. 13th slide, can you go over exec? We did go over it yesterday. So it's in yesterday's class towards the end. And let's not break flow right now. Yeah. How layers are different, images are related. So yeah, as I said, if the base image is the same, then this layer can be reused across two different Docker files. We'll see that very soon. If you've seen the YouTube tutorial on Docker by me, you should be fine. You don't need to attend this class. All right, let's get back into it. Now try to build this image. It already has a Docker file. It looks like a straightforward Docker files. It has some code base we don't need to explore. Try building the project. Backend. So this is the command that I'm running in the week 15 live 2 folder where the Docker file is present to build the image. What is building the image? This is me creating an image for my code base, just how someone has written a Mongo image for the MongoDB code base. Someone has written a Postgres image for the Postgres database. I am creating one for my own backend, which is, a simple backend application. I'm creating an image from it. What is an image? We discussed yesterday, but it's this code base, the file system, Node.js library, all the things that you need to start an application like this. If I run this, you will see it says 1/6 getting this. It's not cached. It's actually still cached. It doesn't say cached over here, but it is still cached. I'll share later why. And then it says the second layer is also cached for me because I was doing the same thing a while back. And third, fourth, fifth, and sixth are not cached for me. How is the first one cached? It doesn't say cached over here. One, it came, as you can see, it happened very quickly. This step on my machine, which is why I know it was cached. And secondly, if a layer is cached, then everything before it is also cached. If a layer ever becomes uncached, then everything after it also becomes uncached. This is a weird reason. I tried to Google before the class why I don't see cached over here, but this is also cached and this is also cached. Given the second layer is cached, you can almost confirm / claim anything before it was also cached, because if this wasn't cached, then everything after it cannot be cached. Layers cannot be cached. If there is one uncached layer, everything else after it will be uncached. Cool. So you might have run this. You might see something else, by the way. You might see this is cached, this is not cached. You might see none of them are cached. Doesn't matter. First time, you might see some random output, but try the same command the second time. Try to rebuild the image another time. And this time you'll see 2 is cached, 3 is cached, 4 is cached, 5 is cached, 6 is cached. 1 is also cached. You don't see it written over here, but everything from here to here is cached. Run it 3-4 times and you will notice it's happening very quickly, because it's like, bro, ye to maine pehle bhi banaya tha. I made this before also. I made this before also. Nothing has changed in these steps. So I am just going to reuse the layer that I had created before. That is what is happening as you run this command again and again. Do we understand this? Do we understand how caching is working right now? Hmm. 85%. Let's discuss this a little bit more and then we'll take a breather around 7:40 maybe. Until then, let's just focus on layers. For the people who are lagging a bit, it's 85% by the way, for people who are curious. People who don't understand, if the problem is you're lagging behind, it's fine. Try to understand this. And if you did not go to yesterday's session, then this is supposed to be overwhelming. All right, but I'll take questions at 7:40. Okay, cool. So for everyone else, if this is working for you, now change something. Go to source/index.ts and then maybe add a few extra lines over here. Add a few extra lines to index.ts and then try to rerun the Docker build. What do you think should happen? Do you think anything changed here? No, nothing changed. Do you think anything changed here? No, nothing changed. Did anything change here? Yes. You changed index.ts, which means the code that is being copied has changed, which means this layer should change, or can no longer be cached. You cannot use the existing layer because the file itself changed, right? If you use the cached layer, it will still not have my changes. So if you change a file, you will notice this layer becomes uncached and every layer after it also becomes uncached. So if I run this again, you will see 2/6 is cached, but 3 is no longer cached, and 4 is now taking some time, and 5 is taking some time, and 6 is taking some time. It became a little slower. then, if I run this again now, then everything will be cached. But this time only second was cached. Third onwards, nothing was cached because this specific step changed. If I rerun this another time, then everything will be cached. I haven't changed index.ts again. So as you can see, everything is cached. If I again change index.ts, let's say I remove these lines, then it will again be like, okay, I cannot reuse the changes. Oh, this is exactly cached because the file is exactly the same, but let me make it a little different. And now if you look at it, 1 is cached, 2 is cached, and 3 onwards is not cached. So that's what layers are, and that's what caching lets you do. Let's try to look at the slides a bit and understand a little better. And then in the next few slides, we'll understand why this is important. But for now, every line over here, not the expose line, not the CMD line, but everything else, the run, the copy, the workdir, the from, creates a new layer. And if you look at the logs, it'll basically tell you what is cached and what is not cached. It'll also tell you as layers are being created and what command led to a new layer generation. Observations are, the base image creates the first layer. Anytime you run any of these commands, that creates a new layer. And layers can be reused across Docker builds. If you remember, I said, कि भाई, if I take this Docker file and put it, in a separate place, let's say I take everything here and put it in a random folder, and then rerun Docker build. I would hope this caches. Oh, this is showing. Why is it showing an error in the second step? I'm running it in a privileged folder. Let me create a random folder, go to test, and then vdocker file, and then copy everything from here to here. And then run Docker build over here. And you will notice it says second layer is still cached, even though I'm running it in a completely separate folder. Here I was running it in this folder right here. Here I'm running it in a new folder, which doesn't even have my Node.js code. It has some other, let's say, Golang code, but still the first 2 steps it has cached from a different place. So you're able to share layers across images. This is a different image I was creating for my Node.js application. Let's say this is a different image for a Golang application, but the first 2 steps are the same, which is why the first 2 layers can be cached across images. Again, it doesn't say cached over here, but if this is cached, the thing before it was also cached. If someone can figure out why that is, let me know. But yeah, if this is cached, then everything before it is cached, and we're able to share layers across images. Do we understand this? Are we good to go? Let me do a poll after the next slide. The question now is, Sarkirat, why are we learning about caching and layers? Is it even important? Why can't I just build and run? Why do I care? Okay, what is coming in these logs over here, and what do layers mean? I can just take it as a black box, right? You're almost right. You don't worry about this ever. But there are some small practices you need to know of, which is why we're learning layers. For most cases, you don't have to understand what they are. But for one very specific use case, you need to understand them. Let's discuss that use case. It says why layers. If you change your Docker file, layers can get reused based on where the change was made. As I showed you, if I change the Docker file here, then everything else afterwards became uncached, but the first 2 layers are still cached. So if you have a use case where you're building a website, a Next application, a React application, you probably want these number of green things to be really high. As you are rebuilding projects, you want as many things as they can get cached. You want them to be cached, and you want the least amount of things to be uncached. So that's something you optimize for. Whenever you write your Docker file, you write it in a way such that across rebuilds, the number of cached layers is much higher. For example, if you're doing local development, you won't change this version again and again. Okay, let me make this 20, and now let me make this 21, and then now let me make this 19 again. Every time you do this, you get a fresh Node.js distribution from Docker Hub. You don't want that. You don't keep changing this working directory. Okay, chalo, for kicks, I will change this to something else. If you change this, then everything else after gets uncached. Your build time increases. You want to decrease the build time. You want कि भाई the number of green layers should be high, number of red things should be lesser. I want as many things cached as possible. But when you saw in case 1, when you changed the source code, only the first 2 layers were cached, everything else was uncached. Let me try that one more time. If I open Visual Studio Code and let's say run this once, I see some caching, uncaching, doesn't matter. Let me run this twice without any changes. And all the layers are cached now. Let me change the source code a bit. Let me add a bunch of spaces in index.ts. And now when I run this, what happens? Layer 1 and layer 2 are green, but everything after layer 3, 4, 5, and 6 are uncached. If I open this in full screen, 1 is cached, 2 is cached, 3 to 6 are uncached. Can we change the code a bit? Can we change the Docker file a bit to optimize this? The answer is yes. Let's understand how. Case 2. Let's say I ask you to change the package.json. Let's say I say, okay, bhai, we are now going to use Mongoose as well. So please do an npm install Mongoose. And what will this do? This will change the package.json file, which again means, okay, bhai, these two can be changed. These two can be cached, but package.json changed, which means this step changed, which means everything afterwards needs to be uncached. So pretty much the problem remains the same. If you change package.json, then this changes, this doesn't change, this doesn't change. Everything else changes afterwards. How did you change package.json? Usually, whenever you install a new dependency, let's say Mongoose, let's say in the future you might add JSON web tokens, we already have Prisma, but let's say, you add CORS, there are 100 libraries that you might want to use in your project, right? Anytime you run this command, package.json changes and it gets that new dependency. For example, it now has Mongoose, which means this step changed. It's now copying over a fresh package.json, which is why everything gets uncached. But here is a thought experiment. How often in a project do you think dependencies change? If you are a developer, how many changes in a day do you think you make in index.ts or your core logic? And how many times in a day, let's say you change package.json? And the answer is you don't change package.json as often. You don't add dependencies to your project every day. Most of the days, package.json remains the same. Once in a blue moon, when you have a new dependency, when you add, let's say, a script over here, is when package.json might change, but most of the time you're writing code over here. How often does the npm install layer need to change? If you look at it, npm install is something we are running at this point. If package.json doesn't change very often, and npm install only relies on package.json, I repeat, npm install doesn't really care about what you've written here, right? npm install does what? It goes through all these dependencies and starts to bring it to your image. Or if I run it here, it will start to bring these to my machine. If package.json doesn't change 20 times a day, should you rerun npm install 20 times a day? Probably not. But does that happen right now? Yes. If your code base changes and you copy over everything, then if package.json doesn't change, even in that case, you are rerunning npm install. Wouldn't it be nice? Okay, npm install only runs when package.json changes. If anything else changes, if index.ts changes, then we can somehow skip this step. That would be nice. Wouldn't it be nice if you could cache the npm install step, considering dependencies don't change as often? So usually, this is how you will see a Docker file. It will not copy everything in one step. It will copy things incrementally. Look at this new Docker file. Base image is the same, working directory is the same, but it first copies package star, which means package.json, package-lock.json, any file that starts with package, it copies over to the image. Everything in the Prisma folder, it copies over to the image. Then it runs npm install. Then it runs npx prisma generate. This depends on everything present here. This depends on everything present here. The rest of the source code doesn't affect this and this. So why not push these copies first. And anytime now package.json changes, then npm install will rerun. But if package.json doesn't change and your Prisma file doesn't change, then all of this from here to here remains cached, which means only new source code gets copied, and I'm missing an npm run build here. You should have an npm run build here, expose and node index.js. Only these things run. All of this from here to here remains cached as long as package.json hasn't changed, Prisma files haven't changed. And these two don't change very often. What changes very often, Harkirat? Everything else. Index.ts, your actual logic changes. This does not change. So if you copy over the new Docker file, which is slightly incorrect, it should have a build step in there. It should have a npm run build over here. This is the right Docker file. So after you copy it, make sure you have this run command over here in case you want to try it locally. I'm going to give you guys 20 seconds. And then let's try to, build the image again and see if it's any better. Generally, you will notice all projects, have this separately and then copy everything at the end. All the files, which, in case of a Rust project, all the dependencies are in a cargo.toml file. So in a Rust project, you will see copy cargo.toml first, then you will see, a build command, cargo build, and then eventually, here you will see everything else, or, cargo install. You get the idea. Now let's try to rebuild the image. For the first time, let it do whatever it does not matter. Now, as you can see, it has 8 layers because I've added more layers. Harkirat, that means if there are more layers, it means more effort. Not really, right? It's still doing the same things. It's just copying them first and then running these commands and then copying the rest later. Just because you have more layers doesn't mean you added more computation to your image. It still, requires the same level of computation. It's a little bit more because you're first copying it and then copying it again, but not substantially high. And the number of layers is not, the time it takes for a Docker image to build is not linearly proportional to number of layers. It's not like if you double the number of layers, the time will also double. All right. Now let me run it again and you will see everything is cached from 1 to 8. Now, if you change index.ts and save it, what do you think will be uncached? Everything will remain cached until this point. More specifically, this is a very expensive step. npm install brings all the dependencies on your image. So this you want to optimize for this to be very cached, which is what we're doing here. We're making sure that unless package.json changes, let's make sure this image remains, this step remains cached. And that's exactly what is happening, because if I change index.ts and if I rebuild the image, you will notice everything until the 6th point remained cached. Only copy dot and npm run build became uncached. So this is how you defer the source code to the very end. The thing that changes the most, which is, index.ts, your db.ts as more files you have, that you want to do at the very end. That you want to do just before the final build, just before you convert TypeScript to JavaScript. Everything else you want to do first. Every other expensive operation, which is npm install, npx prisma generate. This is not as expensive, but still a good thing to push up the chain. But npm install is very expensive. And by expensive, I mean it takes a long time. So you don't want I changed my index.ts and I'm rerunning npm install, which is why you optimize your Docker file to make sure all of these layers will remain cached. These layers will be uncached, but that's fine. This is a simple copy over the source code. This is a simple npm run build. And this is the final command. This expensive step now is cached until I add a dependency. If I change package.json, let's say, remove mongoose from here, then of course, this will get uncached, but you don't change your Docker, your package.json very often, which is why it should be fine. Let's see if you understand layers now. Poll, or more specifically, why you needed to understand layers, which is, this is the answer right here. surprising random fact, which is I did not know what layers were. And the first time I added a Docker file in the backpack code base, I did not have layers. And then someone actually came and fixed that PR. I don't have that PR right now. It's a very old PR and the whole repository is nuked right now. But this is something that someone fixed. And that was the first time I came to know this is a concept. And you push package.json files above and everything else below. All right. Seems like 90% understand what is layers. See if there's anything else before we move to volumes and networks. No, there isn't. So 90% understand, which I'm assuming means we're good to go. Are we good to go? Shall I proceed to networks and layers? Yes or no? If the answer is no, then I'll take doubts. But shall I proceed? Oh, okay, 80%. So I'll take some doubts. So let's do a 10-minute break here. So 7:50 is when we'll meet back. If you want to drop off, if it's going a little too slow, feel free to drop off. And there's only networks and layers. That's one thing that's left. And then there's Docker Compose. That's the other thing that's left. So 3 things are left: volumes, networks, and Docker Compose. You can come back to the offline video. It's not too difficult. It's been structured pretty well. So I think you'll be fine. I'm looking at Q&A now for the next 10 minutes, and then we'll start at 7:50. Oh. A lot of people are saying voice gone. I'm assuming that's not the case. I'm looking at Q&A, guys. Quick recap. All right. More descriptive slides. All righty. Let's do some description over here. You on your Mac terminal number 1, did a Docker build where there was a Docker file which looked like this from node 20 and then a bunch of other steps afterwards. Doesn't matter what those steps are. This is one Docker file that looks something like this. And you did in one terminal Docker build. Then in another terminal, you did a Docker build. Of course, build has a bunch of other things after that, but -t.ast, let's say, and -t.ast2. You have 2 terminals which are in different folders. So this terminal is in a different folder. This terminal is in a different folder. We're running Docker build over here, and it is using this Docker file. We're running Docker over here. This is using this Docker file. The contents are different for both the Docker files. Only the first line is the same. Both of them are using node 20. What do you want? When the Docker build runs, what will this do? This will go to Docker Hub. The first time you're running it, it does not have the node 20 image. So it will go to Docker Hub and fetch that node 20 image on your machine. It will store that image somewhere. This we showed in the slides yesterday as well. Okay, you usually store this image whenever you bring it from Docker Hub. You can check that that image exists if you type Docker images. If I type Docker images, you will see the Mongo image here. You'll see Alpine. I should see Node over here as well. I could be wrong, maybe not. Maybe one of these is Node. I don't know. Probably. I could be wrong. I think, and I could be wrong. Okay, this is the Node base image. I could be wrong, so don't quote me on that. But this is the idea. Okay, you get it here once. Now, if I go to the other terminal and run Docker build again, should I go to Docker Hub one more time? No, right? That is already present on my machine. So I want to get a cached image over here so that I can proceed to 0.2, 0.3, 0.4, 0.5. Now let's say your second line is also the same. Your second line is workdir/app. Here also it is workdir/app. After this, the logic is different, but first 2 lines are same. So wouldn't it be nice? Okay, whatever image is generated after these 2, when I ran it here, whatever image was generated just after the first 2 steps somehow gets cached so that this other guy can also use the same image after the first 2 steps. That's what layers let you do. What layers says, ki bhai, there will be a lot of reuse. One folder you might have a Docker file that looks very similar to the Docker file in another one. So bhai, make every line a new layer. Anytime a line is written, create a layer number 1. And then when the second line runs, then create a layer on top of it. What does on top of it mean? It means, okay, by given this base image, change the working directory. And then if there's a third line, more layers get added. But what is the benefit of this? The benefit is if layer 1 plus 2, if this thing is used in 10 different Docker files, all those Docker files can get the cached image from here. That is why each and every step is broken down into layers, because there might be a third Docker file where the first, the second, and the third step are the same as the first, second, and third step over here. So then the third image, which has the 3 layers, will now be shared between this guy and this guy. That is why layers are sort of a good concept, a useful concept. Does it really matter across projects, Harkirat? Across Docker files? Not much. I mean, it does matter if you have 20 node projects locally. You don't want to pull this image again and again. But the reason they are more beneficial, or the reason you need to understand them today, is because whenever you're creating a Docker file, you need to create it like this. You need to have this pattern of first copying over packages, running all the package specific commands, and then copying over the rest of the code. If you go to the code of app.100xdev.com and you look at the root Docker file, you will see here also, first all the package files were copied, then the Prisma folder was copied, then npm install was run, and then npm install has a post install command that runs Prisma generate, and then you copy over the rest of the code. Any code base, if you look at, most good code bases, unless they're written by newbie developers like I wrote it, they will first have the package copies, then they'll have npm install, then they'll copy the rest of the code, and then the rest of the things will be present afterwards. That's a high level of layers. If you want a mental model, this is the best mental model. I don't know, maybe in my head, maybe not in your head. Maybe a better model is, this. Okay, what remains cached and what doesn't. And the answer is, whenever a step changes or what happened in a step changes, everything else afterwards becomes uncached because, that image changed. So you can no longer use the extra things that you had added for the existing image. You need to basically change everything afterwards. So you optimize for more number of green layers across builds. And the best way you can do that is this. Why is this best, Harkirat? What exactly are you doing here, Harkirat? What I'm doing is, the thing that changes very often, which is index.ts file, whatever causes the code, the layer to get uncached, I'm putting to the end of the file. I'm trying to push this copy command as low as possible so that whenever the source code changes, which is the thing that happens very often, only these layers get affected. The layers above, or more specifically, this npm install doesn't change if index.ts is changed. This npm install only changes when the package.json changes. You can also optimize this further by doing this maybe. First copy over package.json, then run npm install, and then copy over Prisma, then run this. So that if there is a change in the Prisma folder, that doesn't affect the npm install. So, you can optimize this further, but at the very least, you need to make sure first copy the package.json files, then run npm install, then copy the rest of the things. Now, how are we doing? How was the recap, I guess? Looking at Q&A until then, 3 more minutes and then we'll begin. Oh, wow. 95, 94, going down slowly, but cool. 94 is great. So the task is to make Docker image in layers. Was confused what exactly are layers, but I guess we can just call them steps. You can call them steps. Layers are steps. Step 1, step 2, step 3. Yeah, it's just what they name them. Okay, a few more questions. As we copy package.json twice here, once in copy pack, don't they clash? No, they don't clash. You can also skip if you want. Really, you can skip package.json. You can do something like this. By copy source folder, copy Prisma folder, or whatever. I guess this is good enough, right? So doesn't matter though. If you override it, that's fine. It's the same file that's getting copied over again, right? When we change anything in the source file, do we have to build the image again and again? Well, if you're using Docker to run the project locally, then yes, unless whoever has written the Docker file has written it in a way get hot reloads. You can write it in a way that it hot reloads. What you can do is create a volume to the main source code. What is a volume? We'll get to eventually. But you can create a volume to this source code folder so that anytime something changes here, the Docker image ka file system also changes. And if the final command here is, something like npm run dev, then the Docker images itself hot reloads. So you don't have to, stop the Docker image and restart the Docker image. We'll get to that if and when we, reach this Docker file over here, because this Docker file, sorry, not this one, this one should ideally hot reload. I'm not sure if it does. I think it does. So actually it might not, but either way, if it does not, we will try to convert it into a Docker file that does hot reload, but yeah, we'll get there when we get there. When you copy over src, you're copying over tsconfig as well, which will fail the build. Why? Why would copying over tsconfig would fail the build? Why does npm run build? What does npm run build mean? npm run anything. npm run start means कि भाई package.json में inside scripts, what does start say? And similarly, npm run build, what do you think it means? It means in the package.json, what does this build script do? Which in this case converts the TypeScript code into JavaScript code. Voice problem, a lot of people are saying. So let me quickly do a poll. I think it's just a problem for you most probably, because are we good? The audio is good. %94 says it's good. Hoping that means it's fine. That also means that we will proceed to the next slide, which is networks and volumes. What have we learned until now? We've learned about layers. If you don't understand them, it's fine, because networks and volumes are slightly disjoint from it. These are sort of important to know. Why do I say sort of important? Because even if you don't understand them, your life is still okay for a long time. All right. Networks and volumes are concepts that become important when you have multiple containers running in which you need to persist data across Docker restarts or need to allow containers to talk to each other. This is a high level mental model of what a network is and what a volume is. But before we understand this, let's understand, why do you need networks and volumes? What does it say? It says if you need to persist data across Docker restarts, then you should need volumes. When would I want to retain data across restarts, Sir Kirat? If you are using a database. If you are starting a MongoDB database locally like this, Docker run Mongo with maybe a port mapping. If you run this command, it will start MongoDB for you. Let's say you start to store some data in there, and then eventually you stop the container. Then when you restart this, you will see all your data is lost. Containers are transitory. Whatever data you put inside them, if you kill the container, that data goes away. That was the point of a container, right? If you start a container, you can store data inside. If you stop the container, the data goes away with the container. So if you ever want to persist data in, for example, an image like this or a container like this, you need to use volumes. What are volumes? How do you create them? We'll get to eventually. But why do you need volumes? If a container needs to store data across restarts, it needs to have a volume attached to it. And what is a network? Whenever containers need to talk to each other, then you need a network. Harkirat, in the past, we started MongoDB and I did not have to use a network. My backend application was able to talk to the database. Yes, a backend application running natively on your Mac can talk to this database. But if you start one container that has the backend running and another container that has the MongoDB running, this cannot directly talk to this guy. We'll see this more practically eventually. But if you need containers to talk to each other, they need to be the part of a same network. And if you need data to be persisted across reloads, you need something called as a volume. Let's understand them one by one more practically. Let's understand volumes first. If you restart a MongoDB container, you will notice that your data goes away. Let's practically try this. Let's start a MongoDB container locally. The command is as simple as this. So try to run a MongoDB container locally. I'm going to do the same. Docker run -p port mapping and then Mongo as the image that we're running. If you run this code, MongoDB is running on your machine, right? You can start a Node.js process that is able to talk to it. You can go to MongoDB Compass and try to connect to this database. So do these two things, please. Try to open MongoDB Compass and connect to your database. So MongoDB ://localhost:27017. Put this MongoDB URL here and try to connect to it from MongoDB Compass. If you already have it, if you don't have it, just look at the screen. It's fine. You don't need to do this experiment. And then in the terminal, make sure you have started MongoDB. I'm going to give you guys 30 seconds and then I'll proceed. If you want to try along, feel free to. In a terminal, run this command, docker run -p, port mapping, which is 27017:27017 Mongo. And then in this GUI, if you have it already, if you don't have it, ignore. If you have it, try to connect to this database that you've started locally. 20 more seconds and then we'll proceed. Ten more seconds. All right, now add some data inside. Populate your database with some random data from this GUI. You don't have to create a Node.js application. Just add a new database by clicking this plus button and give it a random database name. And whatever database and collection that you've created, add some random data inside. It doesn't matter what it is. I'm just going to put some default values. And now you're good. You have a database. You were able to put some data inside. What if your container goes down for whatever reason? It crashed. You stopped it manually by mistake. You pressed Command C over here and your database crashed. Your database went down. What do you think happens when I restart the database? Do you think this data stays over there or this data gets lost? The answer is the data gets lost. How can you confirm it? Close MongoDB Compass and try to reconnect to it. And you will notice the dummy data that you added sort of went away. MongoDB Compass is extremely slow as an application, has a very big boot up time. So what did I do? Started a MongoDB container, put some data inside it, stopped the container, and then restarted the container. And now if I connect to it, you will notice the data got lost. The database that I had added, they no longer exist. Why? Because all container data is transitory. Whatever data was stored there got lost when you stopped the Docker container. This is why whenever you're starting a Docker container, a MongoDB container, or generally a database, it's a good idea to attach a volume to it. Because this thing persists even if this guy crashes. Even if this guy crashes, you manually stop it. If you restart it and attach the same volume to this container, that data can sort of be pulled from here. This is why volumes become important for use cases like this. What did we do? Started Mongo locally, opened MongoDB Compass and added some data to it, killed the container and then restarted the container. And we tried to explore the database in Compass and saw that the data did not persist. Now let's do what this diagram shows you. Let's first create a volume, this green thingy. Then when we're starting the container, we will attach this container to this volume and then we will start the container. And then we'll see what happens as we destroy this container, restart this container. Does the data persist or not? So now the first thing you have to do is create this green thingy, create a volume, which is a Docker construct. Just how you can create images, just how you can create containers. You can also create volumes in Docker, which is what we're doing here by running docker volume create and give your volume a name. So run this command first. And it will say, basically it is created. If you get back this volume database, if you get some error, you might have used this specific name in the past. So try to change the name, but Docker volume create, whatever name you want to give it, doesn't matter, will create a volume, will create this green thingy. If you run Docker volume ls, it will show you all the volumes that you have. And this is the one that I just created locally. Now, when you're starting the container, you have to add something extra over there. Docker run, port mapping, and Mongo we already had. This is the extra thing you need to add. You need to say, create a volume mount on volume database, this specific volume, which is mounted to /data/db. The first important thing to know is, what is this /data/db? Where does this come from? I get ke bhaiya -v volume to theek hai, means ke this volume database is what needs to be mounted. But what is /data/db? This is the folder where MongoDB actually stores your data. If you go to MongoDB Compass and add some data in there, it eventually gets persisted in the file system somewhere, right? The place where that data gets persisted is this /data/db folder. If I run Docker run Mongo, and then in another terminal, try to go into that terminal, Docker, if you remember the exec command from yesterday, if I try to go into that container and go to /data/db, this is where it's storing all of my data. So this is the folder I need to be persisted across restarts. If whenever a container restarts, as long as this folder /data/db is stored somewhere else, I'm good to go. I don't have to store my complete file system. Just this folder, which has, the real MongoDB data, whatever you store in MongoDB is present somewhere in these files. That folder you need to persist, which is why I say mount volume database to this thing. Harkirat, for Postgres, will it be different? Yes. For Postgres, the location where they store the data finally might be different. It also might be stored in 3 different places. So you might need to mount, 3 different volumes. But for Mongo, /data/db is where the data is stored. That you need to persist to a volume. So now, if I run this again, the command, after you've created a volume, if you try to run Mongo with a volume attached to the /data/db folder, you will notice, basically if you go through the steps of, killing the container and restarting it, you will notice data persists. So if I open MongoDB Compass and let's say add some random data here, as you can see, it already has some data over here because I had already created this specific volume before the class. But for you, it might not have any databases or might have just the dummy databases. But if you add more data here, if you add more databases, and inside the databases add more data. For example, I added this KD database, and let's say I insert some documents inside. Now, even if I stop the container, I have stopped the container. If I now try to connect to MongoDB, it won't let me because there's nothing running. MongoDB isn't running on my machine. So if I open Compass again, which takes a long time, takes a really long time. Let me look at Q&A until then. This took a long time. Okay, there we go. And if I connect, it doesn't let me because there's nothing running on this port. If I start it, and when I'm starting it, attach the same volume again and connect to it, you'll see the data has persisted. So that's the benefit of creating a volume. As you can see, this database is still here. Whatever data I had put inside is still present here, which pretty much tells you, okay, we were able to achieve an architecture like this. Okay, irrespective of this pink thing stopping and starting and stopping and starting, the volume is not dependent on it. The volume is like, bro, I am going to stay here. You stop as many times as you want. You restart as many times as you want. Your /data/db folder I have mounted over here. So whatever things were being stored over here, I have them in this volume. Shut them down, restart it, it's fine. Here, can a different container connect to this? Yes, you can start another container, another MongoDB container that's connected to the same volume. And then both of them will be sharing data. Both of them, will pretty much have the same data because they are both writing to the same folder or the same volume in the end. So that's a high level, not a high level, it's like pretty deep actually into volumes. Do we understand volumes and why they're useful and, specifically useful for a case like this? So this is what we've done eventually. The MongoDB container mounts this folder to a volume that we had created. And even if it goes down, as long as you restart it with this volume mounted to this folder, you'll be fine. Are we good to go? Can we proceed to networks next? Cool. 89% is great. Let's do networks really quickly. And then if we have time, we'll do Docker Compose. If not, we'll cover it in an offline video. But 89% is great. Let's understand networks next. They're also, they are useful for a very specific problem, just how volumes were useful for a problem. Networks are also useful for a very specific problem. In Docker, a network is a powerful feature that allows containers to communicate with each other and with the outside world. Outside world basically means the Mac machine. Docker containers can't talk to each other by default. I repeat, there are two Docker containers. Let's say one running a Node.js application and one running a MongoDB application. Even if this MongoDB application has a port mapping and any request on the Mac machine coming to this URL, even if any request on a Mac machine coming to this URL goes here, inside the Node.js container, when you try to connect to localhost :27017, localhost for this guy is the same container. As I said, these are mini machines. So if inside this container you run localhost, it feels like, acha, I am running some MongoDB here on 27017, but there's no MongoDB running over here. MongoDB is running in a separate container of the host machine. So if you want these guys to communicate, it's not as easy as running localhost :27017 here. Until now, we were starting MongoDB in a container, but we were running Node.js here, node-index.js here. We were running our Node.js application on the Mac machine. That is fine. If you run the Node.js application here, then you can visit localhost :27017 and reach this container. But if you're running your Node.js application in a separate container, if you write localhost over here, it tries to find something running on 27017 on that container, which nothing is running over there. For this use case, you need to connect to both of them, or you need to make sure they're part of the same network. They're able to talk to each other. That is why networks are useful. Localhost on a Docker container means its own network and not the network of the host machine. Localhost over here doesn't mean Mac ka localhost. It means my localhost, as in it'll try to find something running on 27017 on this container. How to make containers talk to each other? You need to create a network, very similar to how we created a volume. In the last slide, we created this green thing. Now we need to create this blue thing and tell each of them, okay, bro, you are part of this network. And then it's pretty straightforward what needs to be done from there. So step one, I have another repository which has some MongoDB code in it. So if you open source/index.ts, you will notice it imports, a db.ts file. If you look at the db.ts file, it has a bunch of MongoDB code inside. So let's try to clone this repository locally. Let's understand, basically what we need to understand is this. How does this URL change? Do we write localhost over here or something else when you're, creating a use case like this? So clone the repository. You don't have to understand the application logic, even though it's fairly straightforward. It has like two endpoints, one post endpoint to create a user, one get endpoint to get all the users that exist in the database. No authentication, nothing like that. Very simple MongoDB Express application. Let's try to clone it locally and then try to containerize it and make it run with networks. Oh, let me paste a link. Well, you can find it here, but let me also paste it in chat. Going to give you guys 30 seconds to clone it. I'm hoping it's easy enough. So the localhost for my machine and image will same be ever. No, your machine's localhost is your machine's localhost as in if you go to localhost colon 3000 on your machine, you are visiting your Mac machine's that specific port. If you run it inside a container, you're trying to hit this mini machine inside. So they're different. So volumes are used in production they are used for testing. You will use them in production 100% if you ever Dockerize your databases, but no one does that. No one creates a database inside Docker. What tech stack do you use on a daily basis? These days it's Rust, Node. Yeah, that's it. All right. I think we're at 30 seconds. So if you guys were able to clone the repository, let's look at the Docker file really quickly. Looks pretty straightforward. From node 20, this is the working directory. Copy over the package files, run npm install. Copy over the rest of the files, run npm build. Expose 3000, run node index.js. Harkiyat, where is the Prisma line? There is no Prisma in this project. It's a MongoDB project, so it only has MongoDB and Mongoose as a library. We are not using Prisma in this one. Let's try to build this. Docker build. Before we build this, go to db.ts. What do you think the URL should be here? Harkiyat, until now that used to be this localhost :27017/database. This was the MongoDB URL we have used until now whenever we were trying to connect to MongoDB. So let's keep it that. Let's keep this localhost and see if it works. What are we doing? We're doing this. We're going to start a MongoDB container. We're going to start a Node.js container. And as you can see, the MongoDB URL I'm saying needs to be localhost :27017. Just like we did until now. But until now, what is the difference? Until now, we were running it directly on the Mac machine. Now we will run it inside a Node.js container and see if this is able to connect to this MongoDB instance. How will we know if it is connected? As you can see, we have logs over here. So if it is able to connect, MongoDB connected will get logged. If it is not able to connect, then this error will get logged. So after you have replaced this with localhost, try to build this Docker image locally. Docker build -t mongo app dot or whatever you want to call it. After you clone the repository, number 1, change this to localhost in db.ts. Number 2, build your Docker image. Didn't take a long time for me. Might take a long time for you. Mostly not, because we're using the same 20 image and it is cached. But I'll wait for 30 more seconds before I proceed. Build this image. Don't run it yet. Just build the image. This is what we eventually have to do. So we have to run 2 Docker run commands, but we haven't done any of that yet. We've just created this image, nothing else. 20 more seconds and then we'll proceed. All right. If you have built the image, what's the next step? Number 1, start Mongo locally. I repeat, first start Mongo locally, then start this application. So in one terminal, run docker run -p 27017:27017 Mongo. In another terminal, run docker run mongo _app. So first run this, make sure MongoDB is running locally for you. What did this command do? This command started the first pink container. This first pink container where this port mapping has been created. What is this command going to do? It will start the second pink container. It is going to run the MongoDB application. I see the first log. It says server running at this URL, which comes from app.ts over here, or whatever, index.ts. I do see this log. I don't yet see a log from MongoDB. It neither says MongoDB connected, nor it says MongoDB connection error, which means it's trying to connect, but hasn't yet reached a timeout. Let's wait for a few more seconds. And now it says MongoDB connection error, cannot connect to localhost colon 27017. So even though you started a Node.js container that is trying to connect to localhost colon 27017, it's trying to connect to this port on the same container. MongoDB is running on a different container. We need to somehow make them talk to each other. That's not happening right now. This guy cannot talk to this guy. If you run the application natively, I repeat, if you don't run it like this, if you don't run it in a Docker container, and it's very hard for me to exit these usually, I don't know if that's the case for you as well, but let me quickly try to exit everything. Docker kill. So what I was saying was, if I run it directly over here, right? If I run npm install followed by tsc-b followed by node dist/index.js, then you will see it is able to connect to my MongoDB server because this is running directly on my Mac machine. But if I run it inside a container, it doesn't work. Are we good to go? Do we understand this? Can we proceed to how network solves this problem? Do you understand the problem? Oh, we don't. It's taking time. Is that the problem? Let's see. 76%. So we'll take a pause here. No rush. We have time. Q&A is open. Anything specific? Is it just taking time? In Windows taking time? Anything else? Can you tell where Docker is exactly in dev and prod? It's used in prod if you're using Kubernetes or some container orchestration engine to deploy your application. A lot of times you do not use Kubernetes. You still use Docker to deploy your application. Dev may you use it for development. You'll understand that better when we reach Docker Compose, but it makes it very easy to start projects locally. Where did the volume get stored locally? It's on your machine only, right? It's a specific construct on your machine. Now, technically, where is it stored is a good question, which I don't know the answer to, but it's somewhere stored on your machine only. Can you tell us the Docker? Okay, answer that. Repeat. Recap network again. Okay, let me quickly recap network before we proceed. You have a complex application. I repeat, this is your Mac machine and you have a complex application. It uses MongoDB as a database. It uses Postgres as another database. It uses Kafka also. It has multiple, let's say services. Let's say it just uses these two for now, Postgres and MongoDB. And what did you do? You said, Harkirat taught me that bhai, you can start Postgres locally and MongoDB locally using something called Docker. So you started to use Docker to start these two services. This is exactly what we did in this actionable Docker track. I just showed you how to start Postgres locally, how to start MongoDB locally. So your life was pretty good. You had this actionable, you went through this and you understood that MongoDB and Postgres can be started inside Docker containers. Now here in your normal terminal, you ran node index.js for an application that uses both MongoDB and Postgres. So it tries to connect to Mongo localhost 27017 and it tries to connect to Postgres localhost 5432. Of course, there are credentials here, but high level, this is the URL to both of the things. And you saw it worked. This was able to connect to this guy. This was able to connect to this guy. As long as you had added a port mapping over here, as long as you had exposed the ports, your life was good. Your Node.js application running natively was able to connect to these guys. But then when you made this Node.js application also containerized, when you converted this from running on your Mac machine to running inside a container, and into a container is when you saw these no longer work. This container is no longer able to connect to MongoDB and Postgres, even though everything is the same. But rather than running this node index.js in a terminal, in a terminal, you started to run it inside a container. And the reason for that is containers by default can't talk to each other. They can't even talk to their host machine. They can talk to themselves. They're like, I'm a mini machine. I don't even know I have a host machine. I can talk to myself, but they cannot talk to other containers unless you attach them to the same network. Unless you say, okay, bhai, you three are part of the same network. So you three are allowed to talk to each other. You don't even need port mappings when you connect them to the same network. If you connect them to the same network, if when you're starting them, you say, okay, bhai, you are all part of the same Harkirat network, let's say, then they can directly talk to each other. They don't even need a port mapping when you're starting it. That is what we're trying to emulate. In the first part, what did we do? We started MongoDB and we started a Node.js application, and we saw, okay, this guy is not able to connect to this guy. If you look at the logs, if you remember the logs, it said cannot connect to MongoDB. This thing got logged. Now we're trying to fix that. Now we're trying to connect them through a network and see कि हाँ, this container can talk to this container. Now do we understand? I raised my own hand. Lower hand. Do we understand the need of a network? In, specifically in a use case like this where containers need to talk to each other. A lot of times containers don't need to talk to each other, in which case you don't have to worry about networks. But in this specific case, they do. All right, great. So now let's do this thing. Let's introduce a network, which is just a bunch of very simple commands. Let's introduce this thing and try to connect the database and the backend application. So step 1, we've already built the application. Step 2, create a network. Just how we had created a volume, you can create a network. Network is another construct in Docker. So you can create that yellow thingy. This is the command to do it. Docker network create and the name of your network that you're trying to create. If it does work correctly for you, you should be able to see your my custom network over here. And as you can see, it says bridge because there are various types of networks. The most popular one is this bridge network that you use when you try to connect multiple containers. So Docker network create my custom network. What will this do? This will create this yellow thingy. Now we just need to make sure that when this guy starts, we attach it to this network. And when this guy starts, we attach it to the same network. So first, let's start MongoDB. Let's not start the backend process first. Let's not start the backend process. Let's start MongoDB first. What does it say? It says Docker run in detached mode with this volume mount. You can skip this if you want because we're just discussing networks, but ideally you want the data to be persisted also. So there is a volume mount as well. We are giving a name to this container this time. We'll see why that is, but you should give a name to your container. I'm going to name it something else because I already have a container with this name. I'm going to name it Mongo Harkirat class. You can name it whatever you want. And then network. Okay, bhai, please attach yourself to this specific network. Port mapping and Mongo. This network name needs to be the same as the name of the volume that you had created. What am I doing? I'm starting Mongo in the background in detached mode with a volume mount and a name. This name is super important. So make sure you remember whatever name you're giving to it. And then just telling it, bro, please attach yourself to this network. And that's it. What have I done in this step? I have started Mongo. I have attached it to this yellow thingy. And I have also given this a name. For my case, it's called Mongo Harkirat class. Your case, it could be called something else. This name is super important. We'll see later on why. Given you have the MongoDB container running, given that you have this thing running and attached to a volume, we now need to start the Node.js container. We need to start the Node.js container. For that, go to Visual Studio Code. But before you start it, you need to change this MongoDB URL. As I said, localhost means my own network. We need it to connect to MongoDB. And hence, you need to replace localhost with whatever was the name of your container. What was the name of my container? It was called Mongo Harkirat class. So localhost can be replaced with Mongo Harkirat class. Harkirat, this looks very weird. How does this name come in a URL? What is localhost when you put it here? It's just, a URL that points to a DNS. And similarly, this Mongo Harkirat class now resolves to the MongoDB URL inside this container. This is how whatever name you gave it over here, you can put over here, because this name eventually resolves to some IP, which is the IP of the MongoDB container. That is why you can put, a random name over here. This name has some meaning inside that Express container that is starting, that Node.js container that is starting, which is why you can, put the name of the Mongo container here. That's how this guy can talk to that guy. Similarly, if that guy wants to talk to this guy, it needs to, refer it by the name. This name is just a domain name similar to, google.com or localhost. Only in the context of that container, this name resolves to the IP of the other container, which is why this looks weird but works. That's the only thing you need to do. What did I do? Number one, started MongoDB. It has a few extra arguments this time, and starting the backend application by running again the same command you can copy from here. Let's see what the command is. Docker run again in detached mode. Port mapping is from 3000 to 3000. Name, you can give it whatever name you want. This doesn't even matter because MongoDB doesn't need to talk to this guy. So you don't need to worry about the name for this guy. Network, the same network that we had attached MongoDB to, and the name of the tag, which I totally forgot what was the name of this specific image. I called it Mongo application. So Mongo underscore app. For you, this image tag will be whatever you used when you were building the project that you got from GitHub. I'm hoping that's self-explanatory. If not, just run the build command again. So, run docker build -t mongo underscore app dot. Actually, you have to do this. Since you changed this URL, you need to rebuild the application because the new image needs to have this new URL. So first rebuild the image and then run the docker run command. If you had already run it, then kill the container and restart it. How can you kill the container? Docker ps to see the container and then docker kill container ID to kill it. Don't kill the Mongo container. Kill the Node.js container in case you started it, because you need to first build it again. You need to have this change in that image. And now you can run this very long command, which will run the Mongo app image with the new MongoDB URL. Maybe don't run it in detached mode and run it directly. And as you can see, it says MongoDB connected. If you do run it in detached mode, then also you can see these logs. Let me show that really quickly, and then I'll recap everything. But if I stop this container that I had just started and then restart it, this time in detached mode, and give it a new name because I already have one with the other name, I can see the logs of this Mongo app by doing this docker logs and the container ID. And if you look at the logs, it says MongoDB connected, which means the final thing also happened. I was able to start the Node.js container. The important thing is, what is the URL that I gave it? What is the URL that I gave it for the MongoDB URL? And the answer is, MongoDB : name of basically this name right here, :27017. Too many things to chew. We'll probably take a pause here. But yeah, this is the MongoDB URL that I gave it, because that's the name of the other container. This guy is attached to this guy. Cool. A lot of things we did. Let's do a poll and see where we're at. I think I went a little too quickly, so I will happily recap. You can also call it here, and I can cover Docker file. It's the last thing that's left, the Docker compose file, in an offline video as well. Let's see how we're doing. Oh, yeah, decent. 73%. So let's call it here then. The only thing that's left after this for the people who are curious is this last slide for Docker compose, which is sort of important. So I'll cover this in an offline video. I'll try to cover this by tomorrow and post the video. This Docker compose and how to push images to Docker Hub, I'll try to post by tomorrow. So feel free to drop off now if you have no more questions. I will look at Q&A, try to answer a few questions, and maybe explain volumes. In Q&A, is there anything specific you didn't understand, or do I just need to recap one more time? So guys, feel free to drop off for the people who understand everything. And everyone else, let's look at this. Every time you do Docker and Mongo, it starts a new container. So is it okay to say that data persists across stops and restart until you kill the container? Until you kill the container, it does work. It does persist, but as soon as you kill the container, the data goes away. Why Docker has Linux OS when running containers? It's a snapshot of a Linux image every time. Depends on what base image you're using. If you're using the Node.js image, if you're using the Ubuntu image, then it has Ubuntu as the OS. If you use something else, I don't know if there's a Windows image, probably not. But yeah, that's the high level. Let's see a few more questions. Considering you're using TypeScript, how would hot reloading work? I can show you. You can try to build it. I don't think this thing has it. The code 100. I don't think this code base has hot reloading right now. I could be wrong. I don't think it has it. So happy to either do this in a video or we can try this right now as well. What is the name flag in the last command? It is how you identify this container. It gives the name to the container, which wasn't important for us until now. It became important because we want to allow containers to talk to each other. So whatever name you give to this guy is what you need to put in the URL over here, which is why the name argument became important suddenly. All the Notion people I'm coming to very soon. Just curious, you can run NVM. You can run NVM on Ubuntu Docker. Yes, you can. Yes, you can. In Docker networks, are all the ports shared? No. So network doesn't mean they're part of the same network. It basically means you can connect from this guy to this guy. You connect from this guy to this guy. It doesn't mean they're part of the same network. You can have something on 3000 here, something on 3000 here as well. I think, I could be wrong, but I think 99% sure that's true. Why deploy Docker container in a prod? In production, you use Docker to deploy because you use Docker in production because in production you have multiple servers. You don't have one. This is server number 1, server number 2, server number 3, so on and so forth. And it's much quicker to start an instance of a container. It's much harder to, start the machine and then install Node.js. And then install Nginx and then install one more thing and then clone the repo. And then, tsc-b and then node index.js. This is very hard. Okay, start a container and run it. It's not hard. It just takes a long time. Versus images can be cached very quickly, which is why you can just get the whole thing in one go and just simply run a single command that starts it. It already has your compiled code base there, which is why you use it in production. Sir, how does it volume work in an actual project? Is the volume created pushed to Docker Hub? Oh, no. Volumes are not pushed to Docker Hub. It's just a local concept right now. Eventually, we will see something called persistent volumes when we reach Kubernetes and, when you actually push it somewhere or have a volume somewhere. This is currently just for when you are running it locally or when you're telling your friend to run it locally. Okay, bhai, first create a volume on your machine and run it. Okay, a bunch of Notion docs now. How to deploy a container in prod? The dumbest thing is, get an EC2 machine, put Docker over there, do a Docker run. That's the dumbest way. Should you do it? You can do it that way as well. As in, start a machine and just rather than running node index.js, rather than doing this on that machine, just do a Docker run image and you're good to go. First, of course, you have to install Docker on this EC2 machine, but then you can just run this command. That's how you can do it on EC2 machine. But do you usually do it like this? No. Usually the way you do it is, you have multiple machines and what are called pods and, you orchestrate these containers on multiple machines. You can still do it like this if you want to. Like if you want a simple version, get an EC2 machine, install Docker on that machine, and then run Docker run whatever your image name is. Don't understand network? Okay. Please recap. Okay, network recap. Time to recap network from top to bottom. Networks. In Docker, a network is a powerful feature that allows containers to communicate with each other. So the first thing you need to know is containers cannot directly talk to each other unless they are part of the same network. Which means whenever you're starting containers that you want they can talk to each other, you need to first create a network and then attach these containers to the network so that they can talk to each other. That's the why of you need networks. If you don't have this network, this Node.js container cannot talk to this MongoDB container. You need to create a network and connect them via the network, which is why, what was the first thing we did? We said by step 1, build your image from this code base. This is a code base that we cloned locally. It's a very simple application which has MongoDB and a basic Express server. The thing that we changed here was, okay, bhai, what should this URL be? Should this be localhost or should this be something else? So we made some change here. We'll get to what that change is. And then we built the image. Then we created a network. We created this blue thing over here. The Docker network create command creates this blue thingy. The Docker network create, this command created the blue network. And then we started the backend process with the network attached to it. So if you look at this command that starts the backend process, it says Docker run in detached mode with this port mapping. So because it's an Express application, you need to visit it at localhost 3000 with this name. Now you don't need to give this guy a name. The Express application works without a name as well, and attach it to this network. And this is the image tag. What is the image tag, Akirat? Basically, whatever you built this image from. When you cloned the code base locally, whatever name you gave to that image, I'm now running that image. The only extra thing, as you can see, we're doing is we're attaching it to a network and we're giving it a name. This is how we started the backend application. And how did we start the MongoDB application? We said, oh, this looks wrong. We said, now this has a few things. Run it in detached mode. Attach it to a volume so that the data persists. Shakir, when did you create this volume? We created it a while back, right? When we were in volumes. Even if you don't have this volumes for now, it is fine. Like, feel free to remove this -v. We gave it a name. Giving a name here is important. And you cannot give the same name twice. So if you give the same name twice to two containers, it will give you an error. So give it a unique name. And why giving this name is important is because this Mongo name, whatever name you're giving it here, is how this Node.js container will talk to the MongoDB container. This name is what gets converted to a domain name in this container, which resolves to the IP of this other container, which is why this name is important whenever you're giving it, especially in the Mongo container. Attach it to the same network. Port mapping, you don't need a port mapping, by the way. Now, even if you remove this, it will still work because these guys aren't talking, this guy isn't talking to this guy through the host machine. It isn't going to the host machine's 27017 and then talking to this MongoDB container. They are directly talking to each other. So you don't even need the port mapping. You just need the name and the network. And that's how you start this MongoDB container attached to this network. So you started this guy attached to the network. You started this guy attached to this network. The only thing is, what should the Mongo URL be? What should this MongoDB URL be? Given, we want this to resolve to the IP of the other container. The answer is, okay, whenever you start multiple things in the same container, the name of that thing is what you can use to resolve to the IP of that other container. If this other container is on 1.2.3.4, this name is what resolves to it, which is why I wrote Mongo here if I started this with the Mongo name, if I started with a different name, I would start this with a different name. And when we ran this, we saw that it actually worked. That's pretty much it. Do we now understand volumes? Let's see, polls. Of course, you'll have to run all of these commands locally and see if they work for you. But do we understand the flow of the commands and what commands we ran and why it was useful? Still at 90%, which is good. Not great though. But okay, either way, not a lot of people now. So let's open chat. Any questions related to the class or otherwise? Shoot. Okay, not a lot of questions. Start from the top. Oh, Notion doc. How does Docker know your code has changed or not? Step 3. Great question. My guess is, and this is probably true, is it creates what's called a checksum. It basically creates a hash based on the code that it is copying. And if that hash changed, it understands that something has changed when the code is being copied, is my guess. We can Google it. How does Docker know? Not. Have you read this thing? Let's see if we can quickly find the exact answer. But here, my guess is, it creates a checksum. The build cache explained thoroughly here. Starting with the parent image in the cache, the next instruction is compared against all the child images derived from the base image and see if none of them was. When you run, so the package has been modified. See, removing intermediate containers. I will have to find a good answer for this. It's a good question. I also thought of this when I was sort of creating the slides. How does it know a specific layer has changed? How does it know a file has changed, for example? My guess is it creates a checksum. How does Docker know when copying that a file has changed and not to use cached file? Perplexity. Docker will recognize when you change a file, it runs every instruction. You copied only one file, not change when the image is built. Docker doesn't know whether packages change remotely. The only thing it can is the modification of the files during build context, and you modify it will invalidate the cache. But how does it know? Was your question was right? Let's see if AI can help us here. But this will be my last try. Docker exists in file during the build process determine which cache is. I get that, but the question is such as when the files added. Your question was how does it know, right? Is it going through every file and finding the diff? If that was a question, I don't know the answer. My guess is it create some sort of a checksum, but could be wrong. Oh, you had a longer doc though. Let me get to all the docs after I go to the text questions. Today I got an offer from a YC co-founder matching. They asked me for managing the tech part of a full stack graphic design. I told them I am only good in full stack and I can provide all the services. It's a good opportunity. I can start something. Can I get 2 minutes after class? Yes, Kushakra. Ping Rookie and he will give you my number. Difference between -- name versus image tag. It's a great question. So when you run Docker PS, you will see it has the image name, which is the name of an image. What do you tag? You tag the image. What are you giving a name to? The name is being given to the container. So this is the name of the container. This is the tag for an image. That's the difference. Like, it's to identify two different things, an image and a container. By creating a feature akin to WhatsApp status, where users can post videos, images, storing them in S3, employing a time to live index in MongoDB for automatic deletion after a set period. Sounds good. Yet the S3 objects aren't concurrently deleted. So one thing you can do is you can have an So do you want an image to be deleted 24 hours after it has been uploaded or 24 hours after it has been accessed? If it is after being uploaded, in S3 itself, you can add an expiry. I think I've seen this. If not in S3, you can add it for sure in media store. So you can either store your data in media store, which is, not usually, I think it has a similar pricing to S3. I could be wrong. It might be more expensive. But it's usually used for video. I'm pretty sure S3 provides expiry as well. So you can just, when you're creating the image, when you're creating the asset, just add an expiry there. You don't need to have, your own process that cleans things up. But other than that, your approach looks right. Store it in a DB, and then eventually, whenever it happens, send a delete request. I don't know why it's not happening. Should we use any other job scheduler? So first, look at the logs as to why they aren't concurrently deleted. What do you mean concurrently deleted? But okay, either way, I think the right way to do this is add an expiry to the object when you're creating the object itself. Can't install Docker on my Mac hardware, so I did it on Kubernetes. And now it's difficult to follow up. Best thing to get Docker. On it'll be easy to, yeah, exactly. So that was what I was going to suggest. If you get a micro machine, it'll be very cheap if at all, like it'll be free for the first 720 hours. I don't know if a micro machine is enough to run Docker, probably is. So, just get a micro machine in there and then, test this. The problem is a lot of things where visiting on localhost, you might not be able to visit on localhost. So, just make sure you're not visiting localhost, you're visiting the IP of the server. That's it. Quickly, can you tell why do we need to use Docker why we need to use Docker when you use all of this in our local? When we use all of this in our local, you use Docker to start projects. If you currently go to the code base of, let's say this CMS code base, you will see that you can either set up this Next.js project yourself, or you can run a single command. Oh, this is the wrong one. This is the right one. You can run a single command. Where are the Docker files? You can run a single command to start it, but where are the Docker files? Oh, there you go. Because this is Docker file here. So you can, just build this image and start it. Why is that beneficial? Because you don't have to have Node on your machine. You don't need to understand all of these things. And this becomes even more important when we reach this Docker compose file, which will start not just the app for you. It will also start the database for you locally. So you don't need to worry about, installing Docker on Postgres on your machine. It just does it for you. That's why it's a little useful to start local projects. Built an alternative to Blind. Please have a look. Let me check. Sign up. You must sign up with your college email. यार वो तो मेरे पे है नहीं. I don't have access to this email. Looks good. Give me access to an email and then I can share more. Do we have to run npx Prisma generate after db URL though Docker CLI because it shows stable user is not in the given DB? Do we have to run generate in the DB after sending the DB URL through Docker CLI? After sending the Docker CLI, if you are not injecting the database URL using an environment variable, then yes, you need to regenerate it whenever you give it access to the URL. Or if you go to yesterday's class, we injected it via an environment variable, and that works as well. I don't know if that answered your question. Like, tag me or a TA if it did not. Maybe I'll have to look at your source code to answer it better. If we have application utilizing MongoDB Docker container and performing CRUD operations with it, how can we view the data inside MongoDB container? You can just expose it on a port, right? You can also create a port mapping 27017. So your host machine can talk to it. The problem isn't that host machine can't talk to it. Problem was one container cannot talk to another container. But if you run it with a port mapping, your Mac machine can talk to it, which means you can open it in Compass. If we close the Docker container, will it delete all the stored operation data? Yes, unless you attach it to a volume, it will. If you attach it to volume, then it won't. Joke 1 for Bounty Challenge week 2. Why did the Indian math book look sad? Because it had too many problems. Why did the week 2 मेरे को याद भी नहीं है. But दूसरा, second one. Why do Docker containers make great comedians? Because they always bring their own laughs and never say it works on my machine. Joke 3. Why did the software developer go broke? Because he used up all his cash. This one's good. I don't know if it's bounty worthy, but it's good. 3 questions. Let's open a Notion doc. Answer that. I'll open on the Notion docs at the end. What is the blue V? Oh, it's Vimium. It's Vimium. It lets you navigate the browser just like Vim. By creating a feed. Okay, answer that. Answer that. Port mapping always maps to the port for the main machine to access. Yes, main machine colon child container port. So that answer that. Can you please give some use cases of Web3 for a professional overview on it, except for encryption and data transfer? I don't even consider these to be use cases. What are use cases? There's a lot of money in the market. People have a lot of assets. Letting them swap the assets is the biggest use case, be it through a centralized exchange like Binance, be it through a decentralized exchange like Uniswap, be it through an NFT marketplace like OpenSea or Blur. These are, or a wallet that lets you see your assets, I guess. These are the biggest use cases. And then, there's something called an RPC provider, which is a common use case. These are the good use cases because there's already a lot of money in the market. A lot of people like to swap assets. Facilitating that swap is a very big business, like a good business. Why have you written run npm run build? Because maybe you haven't gone through yesterday's class, but run is what tells Docker you need to run the following command when you're creating the image. Is there any limit to the stored data in a volume? That's a good question. I'd assume it's just your machine's volume, but machine's limit. How much data can I store in Docker volume? I would assume it's just there you go. The file system that does try to specific experience. If the instance stops, is there a maximum size for Docker volume? That was what your question was, right? And see, it was pretty Googleable. I'm having the same problem. Okay, no one has solved it though. I've been searching but can't seem to find any solution. I don't see on Docker for Mac. This thing. Here are some relevant links. No space left on Docker. So there seems like there's some sort of a theoretical limit of 400 GB. No, 100 GB plus using PostgreStore, but ran into a bunch of Postgres errors. Was mounting a host directory, did not circumvent the disk space on my Mac engine. I'm also could not extend this thing. No space left. Seems like no one has figured out. It seems like there is a theoretical limit, like 100 GB or some big number. And whenever you hit that limit, it tends to shit bricks. So, but it seems like no one has figured out the answer to this. Let's see. It's possible because the Docker. There you go. Read about what this is and how much space this has. Can you try this thing? The disk space is 64 GB. Sparse image will expand on demand. We currently aren't able to reclaim unused space. We'll hopefully add that feature. Yeah, so there you go. Oh, this is from 2016 though. Could you also try increase? Seems like you can also increase the size. So yeah, try to run off some of these commands. Seems like there's a long theoretical limit. But as I said, you don't use Docker with volumes in production. You use something else, something called persistent volumes, which doesn't have a theoretical limit. As long as you're using something called elastic storage. We'll get to that when we reach Kubernetes. All right, what's up next? Any extension Windows machine for running commands like you do, same extensions will work. So using Vimium and Vim, that's it. Explain the /data/db folder. So that's where, so if I start MongoDB on my, let's say Mac or on an Ubuntu machine, /data/db is where it stores all the data. Which is why when I'm starting a container, this is my Mac machine and I'm starting a container inside it called C1, which is running, Mongo. Then this container will have a folder inside called /data/db, which will actually store all the data. This container has a very big file system, has a bunch of folders, but this is the folder that actually has the MongoDB data. If I go to MongoDB Compass and put some data in there, this is where it finally resides, which is why this is the folder you want to attach to a volume, because only this folder is where the real MongoDB data exists, the real user data exists. This is why you mount this to a volume. All right, let's look at a few Notion docs. Hack, refresh this page with counter questioning as I'm updating it live when you take my questions. Okay. Yesterday we saw how to containerize the backend. How would you containerize the front end? Similar, right? npm run build, npm run start inside a container. The only problem, that's it, right? So for Next.js, npm run build followed by npm run start. For React, whenever you're creating the Docker file, even though generally I'm telling like you shouldn't containerize a front end, but let's say you are, then for a React application, it will be something like this, maybe serve-p3000. You'll serve the front end, maybe the dist folder on a 3000 port, and then you'll have a port mapping to 3000 whenever you're starting the container. And npm install, npm run build. Yeah, this will be the Docker file for a React project. Maybe one thing you need to do is, npm install -g serve. It'll be this, or, some variation if there's a bug here for a React application. For a Next application, it'll be simply this npm build and npm start. And yeah, make sure this starts it on 3000. I think it does. And then just add the port mapping whenever you start the container. What are industry practices for deploying front end and backend? Depends on the framework. If you're using React plus Next, front end ke liye React plus Express, front end ke liye it is some object store like S3 with a CDN on top like CloudFront. We have covered this in the video. In a video, it's the cheapest way to deploy a front end like React. Backend depends on how fancy you want to get. Simple virtual machine, slightly more complex, add an auto scaling fleet of machines. Want to go more complex, deployed in a Kubernetes cluster. Next.js, whatever you did for backend, just do it for Next.js, because Next.js is effectively serving front-end and backend both, but it's effectively an HTTP server that's doing server-side rendering, which is why the deployment remains very similar to backend. This is your Docker file, but after 10 lines, there is no npm run build command. Yes, because it is running it in dev mode. So that Docker file isn't for production. That Docker file is for development, which is why even the command that it runs, if you look at it, is simply next dev. And next dev doesn't need to build, right? Whenever you start a React project or Next project locally, you run npm run dev, right? You don't run npm run build followed by npm run stop. You run npm run dev, which is why this guy also runs npm run dev Docker. It doesn't need to build because it starts it in dev mode. Refresh, you said you're going to add follow-up questions. I don't see follow-up questions. Layered architecture, volumes, and Docker networking. Very nice. Beautiful. Thank you, sir. Let's proceed. What else do left with 0 to 1? Now in 0 to 1, there is open API spec, there is mono repos, there is some performance benchmarking, there's auto-generated clients, there's, that's it. That's it. Paytm project in Next.js end to end. I think that's it. Oh, sorry, there are more questions. What are core? Okay, I answered that. That I believe in, I told you. Whatever makes money is what I believe in Web3. Other than that, there's like so many things people are building, but the ones that eventually, in the long run, even in the bear market, end up doing well are the ones that are real use cases. Versus, you can build a decentralized Uber, but no one's really using them right now. Theoretically, it sounds like a very good use case to build. Chat is open. But only theoretically. If I have a node application running on 3000, if I run 4 containers on my machine, now I have a service running on the same port in the container. I want to connect. If I have a node application running on 3000, I want 4 containers on my machine. Now, if a service is running on the same port in some container, want to connect to 3000 on node app. Can you elaborate this a bit? Okay, so this is what I understand from your question. You have an application that runs on 3000. You want to start 4 containers from it. So if that is the case and you want to start it 4 times, if that is what you want, then just Docker run name of your container and add different port mappings. So first one starts on 3000, and then second one starts on 3002, and then the third one starts on 3003, so on and so forth. If that's what you want, I don't know if that is what you want. So maybe elaborate a bit on the question. Going to ignore a salary wala question. Why you tell us some good repos to look at prod deploying Docker? Will you tell us any prod deploying Docker file? So yes, you can. It's not a good repo, but a very elaborate repo is P5JS Web Editor. P5JS Web Editor has a production Docker deployment, which seems like is something you want. So P5 JS web editor. Oh, sorry, GitHub. If you look at their Docker file, they actually have something called multi-stage builds, which we're not discussing, but it's a good thing to know. So if you look at Docker file here, they have like, this production build. Yeah, this is a decent one to look at. Is there anyone else that has openly a production Docker file? I don't think so. I can check. I don't think they have Docker at all. I could be wrong. No, they don't. Where else have I seen like a Docker file.prod? I have seen it in a few places. I just can't remember right now. But yeah, so the idea remains the same. Okay, this will be the file and it will be built a certain way based on, if you're running it in dev mode or production. Happy to just build one for, so we will probably build one for the BTM project. We'll have a Docker file for it. We'll have a CI/CD pipeline that deploys it automatically, things like this. Oh, okay. Seems like I got access to the website. If I have a Node.js, okay, answer that. Notion doc. Now I get this error when I run the backend. No such file. Did you add a dot? Paste your command as well. Your command looks wrong. So I think you forget the dot. So Docker build -t name dot. I think you missed this last dot. Lal may important out. How can we use Docker with the team for development? If one developer changes the code, he has to rebuild the image and then share it with everyone. No, you only need to share the source code, right? Why do you need to share an image? Your image on your machine is for your local development. If you make any changes, they are for you. If you feel any changes are worthy for committing, you commit the source code and then the other person pulls the source code and rebuilds the image on their side. I think none images you see in terminal are old images which are not set to none when you create a new image with the same name. Probably. Maybe. Important doubt. In volumes, example, you ran docker run and created a Docker container added to the database and you stopped the container, but again you ran docker run. Won't this create a new container? And this will obviously won't have the data. I was able to see data. You should not create a container and you stop the container, but then you again run docker run. Won't this create? It will create a new container, and it will obviously not have this data. I was still able to see the data. If I kill the container, the same first container with the Docker start container ID. If I kill the container and run the same first container with the Docker start container ID. Yeah, if you're starting the same container, then it might be possible. Docker PS. So let's do a Docker kill this thing, Docker start this thing, Docker PS. Yes, if you restart the same container, then you will see the data. But if you kill the container and start a new Docker run, start a new container is when you will not see the data. Interesting. I did not thought of that. But yes, if you restart the same container, of course, you will have, you'll see the data from that container. If I clone Visual Studio Code notification at the bottom right, you got lol. I tried to close the, okay. Let's see. Okay, a few Notion docs. What if we run in CMD? Great question. Run runs every time your image is being built. CMD runs whenever your container starts. This thing does not run when your image is being built. So when you run the Docker build command, this thing does not run. When you run the Docker run command is when this thing runs and none of these run. So that's a difference. You only have one CMD per Docker file. You can have multiple runs in the same Docker file. Is this code optimized? Let's see. Packages on tsconfig, this thing, npm install, npx prisma generate, source, npm run build, looks fine to me. Should we containerize Next.js backend? Containerizing Next.js applications generally, you can. Why are they not so beneficial? Because there aren't a lot of services. When does Docker become very powerful? It becomes powerful when you have a database, a front end, a back end, an auxiliary service. You have 5 different services. And Docker lets you give a single command to run them together. In Next.js, as you saw, dub.sh does not have it because it just has a user can do an npm run start. When it becomes problematic is when they have to start database, locally, and then start a backend, and then start a front end, and then start another microservice, start Redis, and then start Kafka, and then start Postgres. That is where Docker shines. If you have a simple Next.js application, then also it's a little useful because your application will most probably have a database. So at least a Docker compose file, which we'll discuss eventually, lets you do start everything in a single command. Why do we create Docker compose file if you already have a Docker file? There are differences, a lot of differences. Docker file is for a single thing. Docker compose file, which we'll eventually get to, but if you want a high level, it lets you start multiple things in a same command. Docker compose. As you can see, the name has compose, which means composes a bunch of Docker containers. It lets you start, an application and let's say your Postgres image or Mongo image in a single command. You don't have to run two different Docker runs. You have to run a single command. That's why it's beneficial. Can we use Bun in Windows using Docker? Yeah. Off topic. Will you cover microservice architecture? We can. What is microservice architecture? It's just, a lot of small services we will be building a lot of projects which will have a lot of microservices. If you want a specific topic, I guess, system design, probably microservice architecture is something theoretical to discuss as well. So yes, explain session-based authentication using access and refresh tokens. So a lot of people have asked this. I don't know why. So I will create a offline video for it. How do you perform aggregations in Prisma? Aggregations in Prisma. I know aggregations is some so there are multiple types of aggregations. Do you mean this, which is like grouping data together? And then if that is the case, then this is your answer. Or, there's another thing called aggregation, which means you get a lot of data dump and then you aggregate all of that data dump into a new database. If you meant this, which is like grouping data together, then, this is what the first Google result gave me. Let's see what it says. Allows you to aggregate on the number fields. So is your question how you can do like a count star or how to get an average, things like these? The answer is yes. Then you'll find your answer here. Okay, you can find the average of the age in a database by running this command. If this was your question, here's your answer. If you meant something else, if you meant data aggregation in big data, then I don't know if Postgres lets you do it. I could be wrong, but maybe seems like this is what you wanted to know. So here's your answer. Okay, there we go. Cool, guys. Any other question, or can we call it? Okay, a few questions. Why do you have so many dangling images after you rerun the Docker build command? Someone said this. I think that's right. As you create more images, you have, and you give them the same name. So you have, these nuns. So that sounds right to me. So if you create backend 3 multiple times, these don't have the name anymore, but you still have that specific image over here. You can get rid of it. I think you can just do a Docker RMI something dash dangling or something like that to remove all the dangling. So there's some command that lets you delete all those dangling images as well. If not, you can go one by one. But yeah, I think the answer is right there. Okay, if you create multiple images with the same name, the old ones get renamed to name. Those are the dangling images you see. For running tests on your application, do you spin Docker containers to host a database in your CI/CD pipeline? Yes, I have seen that. I have seen exactly what you're saying. Okay, you start databases using Docker in your CI/CD pipeline. Will caching of layers also help when we run GitHub Actions? Probably not. Probably not, because every time you're running GitHub Actions, they're probably running on a fresh server. So most probably, if I had to guess, mostly probably this is true. There is no caching that will happen in a CI/CD pipeline because every time the pipeline runs on a fresh server. It's hard to put questions in chat. How can we upvote questions like this? So we tried to build something like this. Didn't really follow through on that. But if you can build something, that's easily navigatable. We have too many applications, which is why, it's a little hard to do it. UI looks pretty janky, if I'm being honest, sir, whoever posted this. But functionality wise looks decent. But yeah. Oh, I like that you have images and animations. But yeah, clean up the UI a bit. Pretty decent though. Seeing the problems with Play Store and App Store, isn't it a good idea? Yeah, this is another one of these. Why is building a decentralized app store a good use case? Build a centralized alternative use case. This thing, right? App store. How does decentralizing it help you at all? Doesn't really. all of these like feel like you need to do them in a decentralized way. A lot of times, you can build centralized, centralized alternatives for this. That's a lot of questions. Let me first go to the other one. First of all, thank you for the code. I'm able to build things on my own because I relied on tutorials. Please make sure 0-1 final pair Paytm clone should contain everything you discussed till now, including bcrypt. Yes, it will. Recoil. Yes, it will. Nextauth. Yes, it will. You haven't covered reverse proxies in detail. Can you make a detail? I think we did cover it in detail, but let me do a poll. And if this, so I'll do a poll today or tomorrow with a bunch of offline videos. Then you can just upvote. The most upvoted ones is what I'll start to pop off. Please review my portfolio. Let's see. I don't have a lot of. I've seen similar ones. I create a different one. Create a simple, portfolio. This one is a very obviously known clone from somewhere on YouTube. TAs are not very responsive. Often take more than 24 hours to ping him. Can you ping the name of them to your TAs to Rookie and share some screenshots of when you tagged them and they did not respond in 24 hours? You're not supposed to DM them, but if you tagged them on your subgroup and they did not respond, please let Rookie know, and then I'll change them for you or something else. On a very high level, we've done server running, returning JSON and text. Make a project on server running images and videos to the client from an object store. If you have an object store, you never return them from a client, from a server. If you have an object store, you return them via a CDN, and the process there remains exactly the same as the deploy a front end to AWS video. So just how we deploy the front end is you can deploy and serve images and videos from there. You never serve images and videos from an EC2 machine because they're very expensive. The bandwidth cost of serving images and video from an EC2 machine is 100 times more than that of a CDN or something like that. Some outrageously high number compared to a CDN. All right. This is the last set of questions I'll take. Boy, they're like a really long list. Third-party image data storage location. How do you know if MongoDB stores data in /data/db? Oh, good question. I Googled. Docker run Mongo with volumes. And what did it say? It said your volume :/data/db. So I never Googled this. The first, I never really went to the depths of where do they store data. I Googled ke, how do I persist data? It gave me this. If I do the same thing for Postgres start Docker with volume. It'll probably give me, where I need to mount. So yeah, there you go. /var/lib/postgresql/data. So this is where Postgres stores data. So that's how I found it. Good question. You went kind of fast for networks while doing it on the terminal. So flags like --name are difficult to grasp and pick up. While I understood this, but it would be great if you could go over them again. Then you recalibrate, great. But yeah, I would presume it would become very important going forward for Kubernetes. Sure. Blind mounts. Nothing about blind mounts. How we do coding inside a Docker container while hot reloading. By blind mounts, you mean what we saw here in Stack Overflow? I think, let me Google what it is. It mounting a folder on your machine to the other thing? Did you mean bind mounts or did you mean blind? Or did you mean you didn't mean bind mounts? Basically, mounting a folder on your machine to a folder on the other part, right? That's what you mean. Is that what a bind mount is? Let's see. Volume mounts. A volume mount is great choice when you need it. A bind mount is a mount where you share a directory. Yeah. We probably need to cover that if you need to cover, hot reloading in Next.js. In any project. Yes, there is no other way to do hot reloading. There's no other way to hot reloading. We will have to cover bind mounts. So this would have come, even though I would have forgotten it, I wouldn't have named the thing, but I would have showed mount a folder to a folder. Docker cache invalidation and checksum calculation. Also, when you were correct about how Docker checks if the file changes images, Googled a bit. Docker determines whether a file has changed and hence whether the cache needs to be invalidated by recalculating the checksum for every file and copy or add of instructions. That makes a lot of sense. Whenever you're finding diffs like these, checksums are the way to go. Like most projects you will see will not, find a diff or maintain what a file had. They will have some sort of a checksum. Good to know that this is what they do as well. Using Docker in production. How do you code on Docker containers? For example, for the CMS repo, how do you manage a piece of code for production and one for dev, which has separate container specific commands like for the MongoDB local host you did in MongoDB app. Isn't all this too much things to remember? Do you have? Oh no. I did that here, but generally for things like these, you have environment variables, which are different for local setup and prod setup. I don't have a link for this, but generally you want to optimize for a single command: npm run dev, or docker start dev starts everything in dev mode, and then npm run prod or docker start prod starts everything in prod mode. These are good questions, by the way. So I'm going to refresh. I see nothing else here. But yeah, right now we copied the change the URL and everything, but eventually when you reach, so if you look at the Docker compose file here, let's see. As you can see, the database URL we inject as an environment variable here. So no, it's not expected from the developer to replace this in the code base. It gets injected. So yeah, that's the goal, is to optimize for doing this. All right, cool guys. I think we'll call it here. Thank you all for joining. This was great. If you're coming to Bangalore, I would love to meet you guys. Have a few panel of people that are coming, and I'll try to post a few offline videos very soon. All right, let's call it here. I'll see you guys next time. Good night.